Welcome to Mathematical Finance. Today we are diving into one of the most fascinating and powerful tools in modern financial markets, financial options. Whether you are looking to manage risk or speculate on future price movements, options are essential. We will build your understanding completely from the ground up. So, let us get started. Before we look at any math, let us understand why options exist. Imagine paying a small fee to lock in the price of a house for a month. If the value goes up, you buy it at a discount. If the house has hidden defects and the value crashes, you simply walk away, losing only a small fee instead of being forced to buy a bad property. You have the right to buy, but not the obligation. This everyday scenario is exactly how financial options work. They act as a safety net, allowing you to capture the upside of a market while strictly limiting your potential losses. Now that we understand the intuition, let us formalize our language. In mathematical finance, an option is a derivative contract. The predetermined price you lock in is called the strike price, denoted by the letter K. The specific date the contract expires is the maturity date, T. The actual market price of the underlying asset at that maturity date is S subscript T. Finally, options come in different styles. European options can only be exercised exactly on the maturity date, whereas American options give you the flexibility to exercise at any moment up to that date. With our terminology set, let us look at the first major type of option, the call option. A call option gives the buyer the right to buy the underlying asset at the strike price. Essentially, buying a call is a bet that the market price will rise. To play this game and secure this right, you must pay an upfront fee called a premium. If your bet is correct and prices soar, you get to buy the asset cheaply and can immediately sell it for a profit. If you are wrong, you just let the option expire. This brings us to the mathematical representation of a call option's value at maturity. The formula is C subscript T equals the maximum of S subscript T minus K and 0. Conceptually, this means we only exercise the option if it makes us money. C subscript T is the payoff, S subscript T is the market price, and K is the strike price. If the market price S subscript T is greater than our strike price K, the difference is positive, and that is our payoff. If the market price is lower than K, the difference is negative. In that case, the max function outputs 0, meaning we simply walk away. Let us see this formula in action with a concrete example. Suppose you buy a European call option on a stock with a strike price of $150, paying a $5 premium. At maturity, the stock surges to $170. What is your payoff? We start with our standard payoff formula. Next, we substitute our known values, 170 for the market price and 150 for the strike price. Subtracting these gives us a difference of 20. Since 20 is greater than 0, the maximum function will select 20 as our gross payoff. Continuing our calculation, the option contract itself is worth $20 at maturity. But we are not done yet. To find the true financial outcome, we must calculate the net profit, denoted by the Greek letter pi. We take our gross payoff of 20 and subtract the initial $5 premium we paid to buy the contract. This leaves us with a final net profit of $15 per share. Physically, this means you risked only $5 to secure a pure gain of $15 from the rising stock price. Now that we have mastered call options, let us explore the other side of the coin, put options. A put option gives the buyer the right to sell the underlying asset at the strike price. You buy a put when you believe the market price will fall. It acts exactly like an insurance policy. If the market crashes, you are protected because you can still sell your asset at the higher, locked-in strike price. If the market goes up, you simply do not use the insurance and let it expire worthless. The mathematical formula for a put option reflects this insurance property. The payoff, P subscript T, equals the maximum of K minus S subscript T and 0. Notice that the order of subtraction is reversed compared to a call. Here, the option only holds value if the market price drops below your locked-in selling price K. If K is larger than S subscript T, the term is positive and you make a profit. If the market price is higher than K, you would rather sell on the open market, so the payoff is 0. Let us apply this to a real scenario. Imagine you own tech shares and buy a put option with a strike price of $200 for a $10 premium. A market crash hits and the stock falls to $160. We start with our put payoff formula to find the gross value of the contract. We substitute 200 for our strike price K and 160 for the depressed market price S subscript T. Subtracting the market price from our strike price gives us a positive difference of 40. Because 40 is greater than 0, our gross payoff from the put option is $40. We successfully avoided selling our shares at the low market price. To find the true financial outcome, we define our net profit pi as the gross payoff minus the initial $10 premium. Subtracting 10 from 40 gives us a final net profit of $30. This perfectly illustrates how put options protect investors. Even after paying for the price drop insurance, the severe fall in value allowed the insurance to pay out, netting you a solid profit. Now that we have calculated payoffs mathematically, let us visualize them. On the left, the call option payoff remains flat at 0 until the asset price crosses the strike price K, after which it rises steadily. This shows profit when the market goes up. On the right, the put option payoff rises as you move to the left of the strike price, showing how it gains value when the market crashes. Notice that in both graphs, the blue line never drops below the 0 line on the vertical axis. This perfectly illustrates that an option buyer can never lose more than their initial premium. These mathematical tools are not just theoretical, they are absolutely critical for modern financial risk management. In the real world, options act as customizable insurance policies. For example, an airline company might buy call options on crude oil to lock in fuel prices, ensuring a sudden shortage does not bankrupt them. Conversely, a farmer might buy put options on wheat to guarantee a minimum selling price for their harvest. By separating the right to act from the obligation to act, options provide a vital safety net that keeps the global economy stable. Let us summarize what we have learned today. Options are powerful financial tools that offer choices without obligations. A call option gives you the right to buy an asset, allowing you to profit when prices rise. A put option gives you the right to sell, protecting you and profiting when prices fall. Most importantly, whether you are speculating or hedging risk, your maximum possible loss is always strictly limited to the initial premium you paid. You have now mastered the fundamental types of options.